Hello and welcome to this video about power in circuits. Now we've talked about power earlier on in the topic when we were talking about forces and work done and energy transferred. And in this video we're going to talk about it in terms of electrical devices and circuits. And there are a couple of equations on your equation sheet that you will get in relation to power. One is current multiplied potential difference, where power is measured in watts. Current is measured in amps and potential difference is measured in volts. There's also this equation which we've seen and used before. However, when it comes to electrical circuits, they tend to make things a little bit more complicated by using different units. They tend to relate power in kilowatts, time in hours, and because energy transferred would equal power multiplied by time, energy transferred, rather than being measured in joules, is measured in kilowatt hours. And this is what you see on an electrical bill, this kilowatt hours unit of energy as opposed to joules. So just bear that in mind. Now there'll be a hint in the question as to which units you should use, whether it's kilowatt hours and joules, because they might give you, for example, the power in kilowatts and the time in hours, and that'll be alarm bells to remember that energy is in kilowatt hours as opposed to joules. Sometimes for these questions they'll give you the units by having your answer on a dotted line and then the kilowatt hours afterwards. And then some people get thrown by that because they expect it in joules. So all I want you to remember is that sometimes energy transferred is measured in this different unit, which is kilowatt hours. And the reason they do this is because when we're talking about electrical devices like ovens and things, to keep the numbers a bit lower, they tend to use kilowatts. And because our devices tend to run for a long time, we use that time in hours rather than seconds. So for example, if we wanted to work out the power of one of these filament lamps, we might measure the current flowing through it by one of these ammeters, which will be our I, and then we might attach a voltmeter to the circuit, measure the potential difference across that, which would be our V, and then we could calculate the power, P equals I times V. So let's assume, for example, that this was 5 amps flowing through, the potential difference was 3 volts. We would simply do P equals I, which is 5 amps, multiplied by 3 volts to get a power of 15 watts. You can then use this value, if you need to, in this equation. If they talk about how much energy was transferred by the lamp, or if they talk about the lamp being on for a certain amount of time. For example, they might give you how long the lamp's been on for, and then you can work out how much energy was transferred by that lamp. So just bear in mind that there are 2 equations talking about power, but sometimes in questions they will link the 2 together. What you need to do is show your good practice of underlining the key information in the questions, working out which equation to use, and then thinking about the fact that there are 2 equations if you need to use them. So here are some questions on power in circuits for you to have a go at. What I suggest you do is pause the video, see if you can answer them, and come back and see if you got them correct. So the first question, what 2 things affect how much energy is transferred by the kettle? So we just need to think about our equation that we were looking at before. If power is the energy transferred over time, then the 2 things affecting how much energy transferred is the power of the kettle and how long it's on for. There's a similar question in a recent past paper that asked you that, and loads of people got it wrong because you weren't thinking about the 2 obvious answers. How much energy is transferred by a kettle depends on its power rating and how long it is on for. So question 2, calculate the power of an electric lawnmower that transferred 1,250 kilowatt hours of energy in 30 minutes. So for this one, we need to make sure that we convert our time to hours. So 30 minutes is 0.5 hours. We've got our energy transferred, which is our E, and we need to calculate the power. So P equals E divided by T, So power equals 1250 divided by 0.5, which equals 2500 kilowatts. So for this one, don't worry if you didn't see the fact that this said 30 minutes. You do need to bear this in mind because they will try and trick you out that in the question. If you see the fact that this unit has got hours in it, that gives you a little hint that your time that you're using has to be in hours as well. And finally, for the higher tier, they'll ask you to rearrange the equation. So it says calculate the energy transferred by 1000 watt iron in 2 hours. So we first of all need to convert this 1000 watts to kilowatts. This is a really common thing they'll ask you to do in the exam. Well, they won't ask you to do it, but they'll expect you to recognise that and convert it. So 1000 watts, if we divide that by 1000, we get a 1 kilowatt iron in 2 hours. So our equation that we got on our sheet is energy transferred over time. So if we rearrange that equation, we will get E equals P times T, where the energy transferred is, in this case, the power, which is 1 kilowatt, multiplied by the time, which is 2 kilowatt hours. So our energy transferred here is 2 kilowatt hours. Just like I said, rather than joules, they've put the units in this kilowatt hours, and that's what you will see if you ever have a look at an electricity bill. So bear in mind that they might also link these equations to that power equals current times voltage as well. Be prepared to use both of those together. So very well done if you got those questions correct. If you found this video useful, then please press the like button below and feel free to subscribe. Thanks for watching.